All right, we all know the basics. When the price of something goes up, people tend to buy less of it. That's the law of demand. Simple as that. But the real question, the one that separates the novices from the pros, and the one you're going to need for your exams, is by how much? That how much is exactly what we're diving into today.
So here's our game plan. We're going to start with that core how much question. Then we'll nail down the definition of demand elasticity before getting into the really important stuff. How to calculate it the right way using the midpoint method. Seriously, this is a must-know for any test. After that, we'll see how it all connects to total revenue, take a quick look at the supply side, and then apply everything to some fascinating real-world cases. Let's jump in.
You see, this is what it's all about. Elasticity isn't just about saying, oh, consumption will go down. It's about measuring the size of that change. Take gas prices. Studies show that a 10% price hike might only cut how much we buy by about 2.5% in the short term. But give people a few years to adjust, maybe they buy a more efficient car, move closer to work, and that same 10% price increase could cut consumption by 6%. Elasticity is the tool that lets us measure that response precisely.
Okay, so here's our core definition. Price elasticity of demand is just a fancy way of measuring how sensitive we, the consumers, are to a price change. The formula's right there. You take the percentage change in how much people want to buy, and you divide it by the percentage change in the price. If that number is bigger than 1, we say demand is elastic. It means people's buying habits changed a lot more than the price did. If it's less than 1, demand is inelastic. People pretty much shrugged and kept buying.
So what makes demand elastic or inelastic? You absolutely need to remember these 4 things. First up, substitutes. The more choices you have, the more elastic your demand. Think butter and margarine. If butter gets expensive, you just switch. Second, necessities versus luxuries. You're going to keep seeing your doctor even if prices go up. That's inelastic. But that sailboat? That can wait. Third, how you define the market. A super specific market like Ben & Jerry's vanilla ice cream is very elastic, but a broad market like food? Much more inelastic. And finally, the time horizon. The more time you have, the more you can adapt, making your demand more elastic.
Now let's look at the extremes. On the left, you have a perfectly vertical demand curve. This is perfectly inelastic. The quantity demanded is the same no matter what the price is. The classic example is a life-saving medicine. On the right, you have a perfectly horizontal curve. This is perfectly elastic. It means consumers will only buy at one specific price. If a seller tries to charge even a tiny bit more, their sales drop to 0 because everyone will just buy from someone else at the market price. Imagine a single farmer selling wheat in a massive global market.
But most of the time, we're dealing with something in between. And here's the key visual you need to internalize. Steeper demand curves, like the one on the left, are more inelastic. Flatter demand curves, like the one on the right, are more elastic. Just remembering steep is inelastic, flat is elastic can be a huge help.
And speaking of help, here's a super simple memory trick that'll save you points on an exam. If you see a steep, almost vertical demand curve, just think of the letter I. I for inelastic. It's a quick and dirty way to make sure you've got it right.
Okay, now we're getting into something that trips a lot of people up, so listen closely. When we use that basic percentage change formula, we run into a weird problem. The answer you get depends on whether you're going from A to B or from B to A. And that just doesn't make any sense.
And this table shows you the problem perfectly. Let's walk through the math. Let's say point A is a price of $4 and a quantity of 120, and point B is a price of $6 and a quantity of 80. Going from A to B, the price goes up by $2. Compared to our starting point of $4, that's a 50% increase. The quantity falls by 40 units. Compared to our starting point of 120, that's a 33% decrease. So you divide 33 by 50 and get an elasticity of 0.66. Now let's go backward from B to A. The price falls by $2. But this time our starting price is $6, so that's a 33% decrease. The quantity rises by 40 units, but from a starting point of 80, that's a 50% increase. Divide 50 by 33 and suddenly your elasticity is 1.5. 2 totally different answers for the same 2 points? That's a big no-no.
So how do we fix this mess? Well, economists have a much better tool for the job. It's called the midpoint method. It's designed specifically to give you one consistent, reliable answer, no matter which direction you're calculating from. Okay, this is the formula you need to commit to memory for your exams. Maybe even pause and write it down. It looks complicated, but it's not. All we're doing is, instead of dividing the change by the starting point, we're dividing it by the average, or midpoint, of the start and end points. You see it there for quantity. The change, Q2 minus Q1, is divided by the average of the two quantities, and we do the exact same thing for price. This little trick ensures our base for the percentage calculation is always the same.
And here's the magic. Let's use our same points from before. The midpoint price between $4 and $6 is, of course, $5. The midpoint quantity between 120 and 80 is 100. Now let's recalculate. The price change is $2. So $2 divided by our new midpoint base of $5 is 40%. The quantity change is 40 units. 40 divided by our midpoint base of 100 is also 40%. Now, what's 40% divided by 40%? It's exactly 1.0, and it's the same answer whether you go from A to B or B to A. Problem solved.
Okay, so we've mastered the calculation. Now, let's put this tool to work. The number one application of elasticity is understanding its impact on total revenue. Total revenue is just the total amount of money a seller gets. You calculate it simply, price times quantity.
And on a graph, total revenue is literally the area of the box formed under the demand curve. The price gives you the height of the box, and the quantity sold gives you the width. But the million-dollar question is what happens to the size of this box when you change the price? Well, as you're about to see, it all comes down to elasticity.
This right here is one of the most crucial concepts. Let's break it down. Look at the left panel, where demand is inelastic. If you raise the price, sure, you lose a few customers. The box gets a little narrower. But you make so much more from all the customers who stay that the box gets way taller. The gain in height is bigger than the loss in width, so your total revenue goes up. Now, look at the right with elastic demand. If you raise the price, people are super sensitive. You lose a huge number of customers. The box gets a lot narrower. That loss in width is much bigger than the small gain in height. The total area shrinks and your revenue plummets.
Now let's quickly flip over to the other side of the market, price elasticity of supply. The idea and the formula are exactly the same, but now we're measuring how responsive sellers are to a price change. For things like cars or books, if prices go up, factories can churn out more pretty easily, so supply is elastic. But for something like beachfront property, you can't just make more of it. Supply is fixed or perfectly inelastic. The key factor here is how easily producers can change how much they produce.
Okay, let's solve a classic economic puzzle. Scientists invent a fantastic new weed hybrid that dramatically increases crop yields. This sounds like amazing news for farmers, right? Well, not so fast. This new tech shifts the supply curve way out to the right. But here's the problem. Demand for basic food like wheat is very inelastic. We can only eat so much bread. So this massive flood of new supply hits an inelastic demand, and what happens? The price completely collapses. The drop in price is so much bigger than the increase in sales that farmers' total revenue actually falls. Good news for the world's food supply becomes bad news for farmers' wallets.
This next one is a perfect example of how time changes everything. Back in the 70s, the OPEC oil cartel decided to cut supply. In the short run, as you see on the left, both supply and demand for oil were super inelastic. We couldn't just change our cars and habits overnight. The result? A gigantic price spike and massive profits for OPEC. But look at the long run, on the right. Over time, people bought more fuel-efficient cars, and other countries started drilling for more oil. Both supply and demand became much more elastic. Now, that same supply cut had a much, much smaller impact on the price. Elasticity broke the cartel's power. And finally, we can even use elasticity to think about public policy. Look at a policy of drug interdiction on the left. This reduces the supply. But because the demand from addicts is extremely inelastic, this just causes the price to skyrocket. And remember our rule. For inelastic goods, a price increase means total revenue goes up. So the total amount of money spent on drugs actually increases, which might lead to more crime. Now look at a policy of drug education on the right. This works on the demand side, shifting the demand curve to the left. It lowers both the price and the quantity, which means total spending on drugs definitely falls.
You know, I love this quote. It's funny, but it's also true. Just being able to say supply and demand doesn't really get you very far. The real insight, the real analytical power, comes from being able to answer that crucial follow-up question we started with, by how much? And that is the power of elasticity.
So here's what I want you to take away. Elasticity isn't just some abstract concept for an exam. It's like the hidden operating system of the economy. Once you understand it, you start to see it everywhere. It explains why some businesses have huge sales and others never do. It explains why a tax on cigarettes works differently than a tax on soda. You now have the tool to look at any price change and not just see what's happening on the surface, but to truly understand the deeper mechanics at play. And that is a skill that will serve you well on your exams and far beyond.